everyone, this is a video looking at mainly calculator percentages, but it's extending percentages into the Nat 5 skills of appreciation, depreciation, and adding in some compound interest as well. We've got a starter here, please complete that and then come back on for the answers. Okay, answers to the starter then. For the first question, we have to perform the divide calculation first, using our rules of BODMAS. So the calculation will become 3 over 4 plus whatever fraction I get for 5 over 6 divided by 2 over 3. I'll do that calculation out at the side and then replace it back in after the 3 over 4. So to divide 5 over 6 and 2 over 3, I have to say that would be 5 over 6 times 3 over 2. That will give me 15 over 12, and if I simplify this, I'll get 5 over 4, and I can then substitute that back into replace that calculation. So that's 3 over 4 plus 5 over 4. That seems incorrect, but actually if I look at the calculations, it's okay. 3 plus 5 on the top there gives me 8 over the common denominator of 4. 8 divided by 4 gives a final answer of 2. Okay, we could change that then, instead of a whole number of 2, we could have first made it 2 over 1 by dividing both top and bottom by 4, and then we know that that means it has to be 2 at the end. Question 2, you will first multiply out the bracket on the right hand side, giving you 4x minus 9 equals 10x plus 15. Don't forget that plus 15 as well. You can solve this in any way, so I would probably say take 4x from both sides first of all. Keep my x's positive, so that's negative 9 equals 6x plus 15. Then subtract the 15 from both sides. So negative 9 take away another 15 is negative 24 is equal to 6x. Divide both sides by 6 and we get x equals negative 4. Okay, I've flipped the two terms round there across the equal sign as well for that last step. Right, let's have a look then at our calculations for today. So we're looking to calculate compound interest and then move on to appreciation and depreciation questions. It's the same sort of skills that we'll be using as we look at the questions we do today, okay? So the first thing to do is to find a multiplier, and we'll work out how to do that in a minute as well. Then apply the correct procedure and have your correct units on the end as well. So always read those correct units just to make sure that the final answer is in its complete form. So the multiplier step here is the bit that's the most common bit. It will stay the same through all the calculations that we do. We need to do this process first, change it to a multiplier and then move on with the calculations. So a multiplier can be used whenever we need to increase or decrease a quantity by a percentage. So in this case, what we do is we start with the original value and we assume that the £350 is equivalent to 100%. So if I want to increase 350 by 12%, to use a multiplier, instead of finding 12% and adding it on, I am going to say, well, since 350 is 100%, I'm going to add the 12% on to that 100. That gives me 112%. I then divide that by 100 to create a decimal of 1.12, and that decimal is the multiplier. Okay, I was adding here since we have to increase by the percentage. You might notice this is basically a recap of what we did in class previously looking at percentages. So you may recognise this procedure. Once we have that multiplier, it is 1.12 times by the original, which is 350, and we can pop that into our calculator and get 392 out at the end. A similar process is applied when decreasing by the percentage. So in this case we assume that the 280 is our 100%. We are decreasing, so we're going to have to do then 100% take away the 23% within the question. That gives us 77%. Divide that by 100 to create a decimal, which we will use as the multiplier. So that decimal comes out as 0.77. We take 0.77 and multiply it by the 280. Now this isn't necessarily our Nat 5 level questions, we'll go on to those in a second, but this process, there's only one little tweak we have to make to this process to complete the next 4 examples. Okay, so let's have a look at some of those then. Right, the first thing we look at is compound interest. Okay, so compound interest is a bank's way of getting you to invest or to put your money into their account. So if you put your money into an account, the bank will give you a percentage of that money every year, and that percentage that they give you is known as the interest. So it's added on. Okay, interest is always added on to the original amount. So in this case, since we know it's interest, okay, so invest in a bank account with 5% interest, then we have to say our starting calculation will be 100% plus 5%, and that equals 105%. We divide that by 100 to get a multiplier of 1.05. Now the only difference with this question and the two that we just done was the fact that we are now performing these calculations over a number of years. So again, we may remember this from when we did it in class. I can find out how much will be in the bank account after 3 years by taking the multiplier, raising it to the power of 3, and then timesing it by the original amount. Okay, so that 3 comes from the 3 years. Okay, so it's 5% every year for 3 years, which is why I raise it to the power of 3. We've got to put that into the calculator then, so 1.05 cubed, or power of 3, times 600 gives us 694.575. We're working with money, so we have to make sure our decimal places make sense. Units of pounds with 58 pence on the end. Okay, so the only difference there, we're still getting that multiplier, but the only difference with compound interest and the next few examples that we see is that we have to raise it to a certain power depending on how many cycles we're going through. So this one's interest going in per year, and it's 3 years, so it's power of 3. Two definitions before we go on. So appreciation is when the value of something rises over time, and depreciation is when the value of something falls over time. So if a painting appreciates over time, we'll be adding on the percentage that we're given. If we're told it depreciates, then we're taking away the percentage that we're given. Okay, take a wee snapshot of that, or a wee note of it just to remind you of that as you do the next questions and the ones in the worksheet as well. Right, so we're applying the same process here, we just need to work out what numbers we need to get from the question. So we're always starting with 100%, so you can always write that down first of all. And then now it says, equipment in a factory in any 1 year depreciates by 6%. So that means we're taking away 6% from the original value. So our 100% is always what we start with in these questions. That gives us 94%. When we divide it by 100, we get a multiplier of 0.94. Now the second part of the question says, how much will a piece of equipment costing £20,000, so that's our original, be worth after 4 years? So I'm trying to work out straight after 4 years, it will be the multiplier 0.94 to the power of 4 times what we started with of 20,000. Again, that needs to go in our calculator, 0.94 power of 4 times 20,000. We end up with 15,614.979 and so on. So when we round it and put our pound sign in, £15,614.98. Okay, and again, just make sure we do that 2 decimal places when we're working with money, so always refer it back to the context of the question. If you don't know how to put those powers in your calculator, you can, Google it, depending on what phone you've got. You can have a little Google of how to put power of 4, how to put power of whatever. You can try and type it into your browser as well, or you can ask on the Teams page if you're struggling to do that, and I'll try and explain it either through a video or through text message. So next question then, we are looking for a house bought for £70,000, so that's our original. We are told that the house appreciates by 3% each year. How much should it be worth in 2019? So to find our number of years, 2014 to 2019, that's then 5 years. So our power is going to have to be the power of 5. We've got to get that multiplier first. So it's 100%. We're appreciating, so it's plus the 3%. That equals 103% in total. Divide that by 100 to get a multiplier of 1.03. After 5 years, we then have 1.03 to the power of 5 multiplied by the original, which is 70,000. Again, into the calculator, power of 5 times 70,000 equals 81,149.185. We need to take that to 2 decimal places, remember, since we're working with money, so it is 19 pence on the inch. You won't always be working with money. If you're working with people, for instance, and populations, then you need to take it to a whole number, because you can't get 0.2 of a person. So just relate it back to the context of the question, whatever that may be for your rounding. The last one, so this is one of our ones that is a little bit different. The steps are still the same, but we just have a slightly different method. So we'll start it off the same. We still have 4,500 as our original, because that's what Jamie bought the car for. He is told it will depreciate by 8% every year. So we can work out our multiplier from that. Now this bit down the bottom here asks us, in how many years will the car be worth less than 3,000? There are many, many ways in which you can do this. My most preferred way is trial and error. So I would say, let's find the multiplier first. 100%, take away the 8, since it depreciates by 8%, gives me 92%. Divide that by 100, and I get 0.92. So my calculations are going to have to be 0.92 to some unknown power times by 4,500. Now I don't know how many years, that's what I need to figure out. So this unknown power is the years. how many years it has taken. What I would do here is start to guess. Okay, I would try 2 years and see what happens. I would try, if that's really far off, I would up it a wee bit. Okay, so trial and error. We'll go for 2 years. That would be, so again, pop this in calculator, 0.92 power of 2 times 4500. That gives me £3,808.80. So 2 years isn't going to work. Alright, let's try, it's not far off, so let's not go too much higher, let's go for 4 years. Now you can feel free to work your way through, try 3, try 4, try 5. But I would try and skip through a few of them if you can. So 0.92 power of 4 times 4500 gives me 3,223.77. So we're still not there with 4 years. What about if we tried then, and again you can just keep trying them, let's try 6 maybe, got by another 2. 0.92 to the power of 6 times 4,500. Now that gives me 2,728.59 and so on. So that's given me a number below 3,000, which is what I was looking for. But as you can see, I've gone from 4 years straight down to 6 years. So I need to go back then and check that 5 years doesn't give me a number that is above the 2,700 but is still less than 3,000. So I'll try 5 over here. Now you don't need to write all of these down. When I ask you for it, I'll give you an interactive worksheet as well for this, for the second period of this. When I ask you for the year, I just want you to write down a number for the year. So after 5 years, we've got £2,965.87. Now, since this number here is less than 3,000, then it must be 5 years for the answer. So this is the number of years for the power, so it has to be 5 years. My final answer here is 5 years. Okay, that one there is, as I say, it's trial and error. It's guessing those numbers. If it's kind of as close to what you're looking for, pick a number that's a little bit above. If it's nowhere near, maybe go a few numbers above, and try and pick them. If you come to the worksheets and stuff and you can't find those numbers, please let me know and I'll help you out as much as I can with those as well over the Teams page. Okay, the main questions you will see will be the appreciation and depreciation ones, but I do want to add some of these in as well just to really apply what we've done with the basic calculations. Okay, you will have your work on the Teams page for today. If you can go there now, you'll be able to see what to do, and just let me know, as I say, if you need any help with any of these. Okay, thank you everyone.